In this example, we're going to use our newfound knowledge of resonance in tubes to figure out the length of another tube. So when I read this, it tells me the second resonance length of a tube open at both ends. So that's what I'm going to first do is just draw a tube open at both ends. And I know the first resonance length would be a half a wavelength and the second resonance length is one full wavelength. I really have to learn the patterns here, right? I have to learn those patterns. So this is one wavelength long. That's also really important to know. And it says that the tube itself is 46 centimeters. So this is 46 centimeters. That means one wavelength is 46 centimeters. That means the wavelength itself is 46 centimeters. That's the wavelength of the wave that creates this pattern. Asked me then what would the third resonance length be. So I wouldn't be changing my frequency. I'm just making my tube longer. So when I make my tube longer, how much longer does it need to be to get to the next pattern? And this would be the next pattern. So my next pattern is my, I add another half a wavelength, right? So then I get to 1.5 wavelengths long. So if I know that one wavelength is 46 centimeters, then 1.5 wavelengths, or 1.5 times 46, will give me the length of my tube. So it's kind of like understanding the patterns, right? There's no real equation here. It's understanding what they're telling you, what the patterns are and what they mean. What it means is I will get to 69 centimeters and hit the next resonance length because my next resonance length is 1.5 times my first resonance, or my third resonance length, I apologize, is 1.5 times my second resonance length. So that means I can write my therefore sentence.